I need you guys to, as soon as this pops up, to log into the Nearpod. As soon as this gets on there, there's the code. So join.nearpod.com. Join.nearpod.com. And the code is D7FRZ. Get logged into that so that we can, I'm going to show you guys some stuff today with an online calculator. I know that the people in class have TI-84 calculators, but those of you guys that are at home don't have that. I'm going to show you guys how to use a Desmos calculator. I think some of you probably used it in Algebra 1, depending on your Algebra 1 teacher. Does that sound familiar to anybody? Using Desmos? Y'all don't remember doing that at all? No? Okay. We'll get logged into this. Make sure you're doing that quick so that we can get started. And then it's not going to last the whole period, and you'll have some time to work on anything that you need to work on. Okay. Any of you guys need this anymore? Got it, Jojo? Still loading? Here, write down the code because once you log in with the code, it'll go right to where we're at. D7FRZ. Everybody at home good? Anybody need any longer? It's actually the code's in the chat for all you people at home, so I'm going to go ahead and get started so we can get started. So on Thursday was our introduction lesson for Unit 7, function applications. We talked about scatter plots. I think you guys know how to make scatter plots. We use scatter plots with bivariate data that has two variables, not just one. We have an x value and a y value. So that's what we did on Thursday. Simple, starting out with scatter plots, describing what they look like. What does the correlation look like? Today, we're going to expand on that just a little bit. And I'm going to start out with a little analogy, with a little example. Anybody, you know who Michael Phelps is? Who's Michael Phelps? You don't know? Swim dude. Like one of the most decorated Olympic gold medalists in Olympic history. One of the best swimmers in the world. One of the reasons why Michael Phelps is so good at swimming and so fast at what he does is because of his arm span. Michael Phelps is 6 feet 4 inches, but his arm span from tip to tip is actually 6 feet 7 inches long. Yeah, he's literally longer this way than he is tall. And actually, for the most part, almost all of the U.S. men's swim team is like that. Swimmers, coaches look for people with long arm spans. Why? Because they can swim faster. They cover more of the water to make them swim faster, right? This is just a true fact. So I have some data here on the next slide. This data is about local competitive swim club and the height and arm span of the top 10 swimmers. So look at the chart there. The left side is the height in centimeters of the swimmer, and the right side is the arm span in centimeters of the swimmer. Okay, some of them have a little bit longer arm spans than others. The left side, the height, that's our X value. The right side, the arm span, that's our Y value. Keep that in mind. All right. Here's what I want you to do on your computer screen. Okay. This is going to be, we're going to try this. On your screen, a Desmos calculator is going to pop up. Give it a second because I think it takes a second for it to load. Does everybody see this on their screen, on their own screen? You guys at home too? Is it working, Jojo? Still not? Okay. On their own screen. So we're going to use a Desmos calculator today. I am going to, oh, that's the wrong one. Pull up, you can see that I pulled up this, this chart of the swimmer's arm span and height again. Here's what I need you guys to do on this calculator. First of all, it shows you different models here. Today, we're only talking about linear models. So go ahead and close out the logistic model, close out exponential, close out quadratic. We're not going to use those. Okay. Leave the linear up there and the data up there, but close out the other three that were on the bottom. So you're just using it. You don't really need those out there today. We're going to use them on a different day. We're going to, is it working on your phone? Mm-hmm. Cool. All right. Here's what you're going to do next. You see the data? Click the little triangle next to the data so that it opens up. And it's going to pop up with a little table here. Now, it's got already some numbers in there, but we're not going to use those numbers. We're going to use the numbers that I've given you right here on the swimmer's information. So scroll down to the bottom of the table and put your cursor, click it in the last box there. And here's what you're going to do. You're going to hit backspace over and over again until it clears out all the box. Keep hitting backspace until it clears it out. Oops. If you cleared out the top, just make sure you put X1 in there. It's not working on it. Is it working on your phone? Mm-hmm. Okay.
On the data, right?
On the data. And then what you guys are going to do, is put in the data that I have here for the swimmers. The height is the X, I said, so put the heights in here first. Now, the easiest way on a computer is if you put in 172 and hit enter, it goes down to the next one. So I like to do all the X's first and then come back and do the Y's. You can do it either way you want, but it needs to match up. So I'm going to put in all these numbers, and you can do it with me. The reason I'm showing you guys how to do this is because later on down in the week, when we do a new assignment, this is the calculator you're going to use because it's the easiest one to use online. One 172, 173, 179, 180, 183. Three. When you finish that, hang tight. Hang tight for a minute. When you put those numbers in there. The what? I have them up on the screen. You have to look on the screen. For some reason, it doesn't let me put this side by side with that slide. I wish it would. Can you see it? Why don't you move closer? Zoom into this. There you go. Should have done that from the beginning. How you guys doing at home? Is it working for you guys? Let me know in the chat. good. We're going to do this first one kind of slow so that everybody has an opportunity to do it the right way. Hold on, pulling back up. All right, notice how, those of you that are done putting it in, notice how you can't see any scatter plot there anymore, right? So this is what you guys are going to do. Look at the bottom left of the data. You see that little magnifying glass with the plus sign in it? Hover over it. It says zoom fit. You're going to press that, click that once. And watch what happens. Now now you see your scatter plot. Do you still need it, the numbers? Okay, there it is. And now you can see your scatter plot. Take a look at your scatter plot, and before we do anything else, is that a pretty strong correlation based on what we learned on Thursday? Pretty weak correlation, somewhere in the middle? What do you think? Somewhere in the middle? Pretty strong? Why do you think it's pretty strong? It's pretty straight. I agree with Alyssa. That's a pretty strong one. I'm going to show you why here in just a second. Okay. Got it? Okay. Did you click that plus, that magnifying glass? So here's what I want you guys to do next. Take this linear model. You see the triangle next to that? Click that triangle so it goes down. And it pops up some information here. Okay. I want to write down the equation of the line that best fits this data. Okay. Watch this. Click this little circle next to that y equals mx plus b. Watch what happens. It's created a line for the scatter plot. This is called a linear regression line or a linear regression model. It's creating what it thinks is the best line to fit all of the data. And you guys should remember from Algebra 1 that y equals mx plus b is the standard form to write an equation of a line and slope-intercept. M is the slope and b is the y-intercept. Do you guys remember that from Algebra 1? Yeah, a little bit. Here's what I want you guys to do. Take a scratch sheet of paper real quick. Everybody get a scratch sheet. Doesn't matter. Just tear one in half and share it with each other and get it real quick. We are going to write the line of the equation. And I want to write it to the closest 2 decimal places, so the nearest hundredth. Here's how I'm going to write the line. I know that it's y equals. I always got to have y. I'm going to write this nice and big. This is it. We're going to put an equal sign. M, this is the form that I'm going to put it in. M is 1.02198. I'm just going to write that to 2 decimal places. How many decimal places? What is that going to be? 1 point what? Yeah, to do 2 decimal places. 1 point. No, but 0, 2. Yeah. So that's 2 decimal places. All right. I got to write x next because x is part of my equation. So 1.02x. And it says plus b, but what do you notice here? B is negative. So instead of a plus sign, I'm just going to write it as a minus sign. If b was positive, I would leave it as a plus. So I'm going to do minus. How do I write that to 2 decimal places? 1 point what?
42.
Why 43? You're right.
Because
The 8 rounds it up, the 2 up. Good job. I wanted you to explain that to everybody else. Good. That's the correct rounding for the equation. So that line that's put through the scatter plot, this is the equation of that line. And you don't have to do any math. Calculator does it all for you. It's creating that equation for you. You think you remember that process, putting in those numbers and just clicking that linear if I gave this to you? It's pretty easy, okay? Don't forget to click that magnifying glass so it could zoom into wherever your data is at. Okay, we're going to try this again in a little bit, in a few minutes. Okay, here's the other thing I want you to write down and just remember it until we get to there. R. R means something, not the R squared, but the R. Write R down 0.9628. Just write that down on your paper. I'm going to explain R in a few minutes. R stands for the correlation coefficient. It tells us how strong our data is and how many, which direction it's going. It's really important. But I'm going to show you guys this on the next screen when we get there. Okay. Are we good so far? You guys think you can remember how to put the data in? Pretty easy. All right, I'm going to switch to the next slide. And here's what we just wrote down. This is the equation that we just wrote down from the data, and the correlation coefficient from that data. I'll explain correlation coefficient in just a few minutes. Let's talk about the equation though. Let's see if you remember how to do this stuff. Let's say that I have a swimmer and his height is 176 centimeters. How would I figure out what his arm span might be using that equation? What am I going to do? I got to do something with this number, right? What do I do with that number? Well, I have an equation, don't I?
Yeah.
So how do I use that equation?
You multiply the x.
Yeah.
One.
Thank you. Who is that?
Jimmy.
Hey,
Me.
Jimmy. Yeah, I got to plug in. It says the height is 176. We know that height is x. I told you that earlier. Y'all put that in the x value earlier. So let's plug this number into x right here. Okay, grab your calculator. Let's do it. I'm going to plug that number into x. That's what it's going to look like. Y equals 1.02 times 176 minus 1.43. And whatever I get from that, that's got to be my answer. What'd you get, Christian? 178.09. So somebody who has a height of 176 might have an arm span of 178.09 based on our equation, based on that data, right? Does that make sense? Makes sense. We use that equation that it got created for us anyway. This is an example of what's called interpolation. Okay, interpolation, because inside in means that 176. Hey, that fell inside. This 176 fell within this range. It's literally like right in here, right? And this is okay. This is an acceptable estimate. It's okay for us to interpolate when we have an equation that we created from data. Okay, I could get all of y'all's grades for all of y'all's classes in the entire school, and I can create an equation of it. Right? That's called a regression equation. And then I could figure out, hey, little Jimmy's going to come over here at school today. He's transferring from another school district. Let's see what he might do based on what everybody else is doing. Okay, if he's within that range, that is a interpolation. But let me show you a different example. And I didn't mean to use you as an example, Jimmy. It just came out. Take a look at this one. Can you do the same thing? What do you predict the arm span of a swimmer will be when they have a height of 200 centimeters? Figure out that answer real quick. What are you going to do with that 200? Still going to plug it into x? Mm-hmm. Yeah, we're still going to plug it into x. So plug it in. What'd you get?
202.57.
There you go, 202.57. What's different about this estimation this time, though? Where did 200 land? Is 200 within our data this time? No, it's outside of our range of data. This is a little bit different because this is called an example of extrapolation. Okay. Extrapolation is, I'm not going to call it bad, but it's not something that you should do, or you should do it with caution. And here's why. We don't know if the data, remember how those scatter plots, they were trending upward, wasn't it? Like the taller you get, the bigger your arm span is. However, we don't know for sure that that's always going to be the case. Is that always going to continue to happen? We could find more data, but based on this data alone, we don't know if it's going to continue that way. It could just level off. At a certain point, you get so tall that your arm span is only going to get so wide. Maybe. We don't know that. Or so short that your arm span is only going to get so wide, so small. So extrapolation is not a good thing to do. The difference between interpolation, where I picked a number that was inside our data, extrapolation was a number outside of our data. Okay, a little bit different. Interpolation good, extrapolation not so good. Not necessarily bad. All right, so here's the last thing. This is the new thing, the other new thing that I'm just going to show you today. The R value, that correlation coefficient. What did you guys write down a few minutes ago about that R value? What was it? 0.9628. Here's what R does. It tells us how strong it is and which direction it's going between the two variables. R is always going to be between -1 and +1. And your value is already between -1 and +1. All right. If R is positive and yours was positive, then it has a positive correlation. The data points, the dots, the scatter plot's going to be going up. Wasn't it going up on the one that you guys just did? Yeah. And it was the closer to 1 it gets, the stronger that it gets. So 0.96, what did you say here? 0.9628. How close is that to number 1? Really close. Did Alyssa hit it on the head a second ago when she said it was very strong? Yeah, it is super strong. Okay. Some of you are like, it looks kind of weak. Alyssa was right. It was very, very strong. And we can prove that because that R value was really, really close to 1. The closer to 1 that it gets, the stronger and closer the points get together. But what happens if it gets closer to 0? It's going to get weaker. And what's going to happen to the scatter plot? It's going to start to spread out more. All right. If R is around 0 or equal to 0, guess what the scatter plot's going to look like? All over the place. Okay. There's no correlation if R is around 0. But the opposite happens if R is negative. What do you think is going to happen to the scatter plot if R is negative? Instead of going up, it's going to be going down. And look what this scatter plot looks like if R is negative. I know for you guys in class, it might be a little hard to see. But the scatter plot is going down. But the closer to -1, the stronger that it gets. So still, if it's closer to 0, the more weaker it gets. Let's take a look at this and have a little matching game. And I'll help you guys out too. I'm going to open this up student view so you guys can check this out. It should show up. Is it refreshing on y'all screens? Does it show the little matches? Hold on. The layman Wi-Fi has been pretty slow today. I don't know if y'all noticed. I don't know if for the beginning of each week, I don't know why it always seems like it's super slow. Okay. We're almost done here. Oh no. There it goes. Uh-oh. Who did we lose? All right. I'm going to help you guys start out. We're going to match each correlation coefficient. Remember, R value is the correlation coefficient with the correct scatter plot. Let's start out with the strongest one, though.
1.
Okay, 1 is the strongest one. So this is the strongest one, and it's got to be positive, which means it's going up. Which one of these has to be 1? Your screen might be a little different because it's jumbled up. The one what?
On the bottom?
Which, the one down here on the right?
Yeah.
Is there not one that's stronger than that? Ethan?
Also, oh no.
Yeah.
Oh, it's the other one.
The one right below it is definitely got to be 1 because look, it's almost a perfect, or it is a perfect correlation positively. So that's that one. Which one's the strongest one negatively?
The number?
Either one.
Oh.
Okay, negative 0.976. So which one has to be which one's the strongest negative one? I should say, which one is the strongest negative scatter plot?
The one next to the.
This one?
Yeah.
That one? Yeah, that's got to be it, right? That one's super strong negatively because it's close to -1, and it was almost a perfect line, except for 1 or 2 that were kind of out of sync. Ethan, see if you can finish doing the scatter plots, the matching on your screen. You awake, Ethan? See if you guys can finish matching the scatter plots, and it'll tell you too. See if you can get them all right while I take roll. Let's see. This has got to be the next strongest positive one right here. This has got to be it right there. As these start to get more spread out, it starts to get harder. Like this is super spread out, but you can still see that it's kind of still trending upwards a little bit. They're just really far spread out. This one's the 0.276, right? Are you guys able to get them all matched? So you guys see how that R value works. Positive R value going up, negative R value going down. Closer to 1 or closer to -1, it's stronger. The data points are a lot closer together.
Even if it's closer to -1, it's stronger.
Yeah, even if it's closer to -1, it's stronger. That's why this one right here is negative 0.902 because it's super strong, but it's strong negatively. So they're closer to 0 than it is, the more spread out. But if it's positive, it's still trending upwards. If it's negative, it's still trending downwards. So that's a good question. How are you guys doing this? I had to switch back to the teacher view to see how you guys are doing, and we'll go on to the last. Hopefully it doesn't freeze out. Anybody need more time matching? Let me know now. Okay, I'm gonna give you guys another minute or so match, and then we'll go on to the last thing. So on the next slide, I'm gonna give you guys another data set, and I want you guys to come up with the equation. You're gonna type it into the Desmos again, and you're gonna write on your scratch paper the correct equation this time, and then I'm gonna ask you to pick the right equation. Okay. I'll give you guys about another minute. Still waiting on a few people to fix these last matches, it looks like. How you doing, Leslie? Yeah, I'm sleepy too. Did you get to finish? Okay. Then moving on to the last thing. So take a look at the screen that you have here. I'm gonna do what I did last time. I'm gonna minimize this and leave the put the picture of the ice cream sales. Here's an ice cream shop that's tracking how much ice cream they sell versus the temperature on that day. The temperature's in Celsius, so I know that's not what you guys are used to. The X value is on the left side is the temperature, and the Y value is the ice cream sales. Okay. On the next slide, you're going to put in the data just like last time, but I'm not going to do it for you this time. I'm not going to do it with you guys. Put it in yourself, look at the linear, and write down what the equation would be. Okay. Write down the equation of 1 decimal place for the equation, but 3 decimal places for the R value. Okay. You guys got it? All right. I'm going to go to the next slide. I'm going to move this over. I'm going to put the right. I thought this was going to let me. Okay, go ahead and start clearing out this data. And as soon as this opens up, there you go. There's your data to put into the thing. And you're going to get into the table. And you're going to, remember, get the linear equation and write it down on your scratch paper. You're going to put it on the next slide. We'll see. Let me know if you need help. Yeah. Does that work?
Yes.
Oh, shoot. So remember, temperature is X and ice cream sales is Y. Let's practice. This is the last practice you're going to have on this. Because on Wednesday's assignment, y'all are going to be doing it completely on your own. I'm going to show you one more thing, and then you can do it on your own. I'll give you guys about a couple minutes. Should take you no more than like 3, 4, 5 minutes to put all that in. Don't forget to click, if you want to see the scatter plot, click the little magnifying glass on the bottom left of the table. Now, those of you guys in class, I'll show you a little trick. If you guys are going to be in class when you're doing these assignments, I can show you how to do it on the TI-84 calculator. I'm not using these today. This is X and this is Y.
Is it 2 decimal?
Write the equation to 1 decimal place, and then the R value to 3 decimal places. Okay. About 2 more minutes. I think you should have enough time to type this in. Once you type it in, it pulls it up on there automatically, and you just have to write down the equation. Does anybody at home need more time? Oh, I see a question. Which R value? Always use the regular R value, not the R squared value. Always use the regular R by itself, not the R squared. All right, you guys at home need any longer? You guys here good? Y'all have an equation written down? Christian? Did you write your equation down? Alyssa, you write your equation down? Don't forget to write y equals. Y equals, plug in your M, plug in your B. Okay. I think you guys have had enough time. You should have already inputted it. You should see it on your screen. You write down your equation, write down your R. Write down the R real quick. Are you doing something else, Alyssa? Are you doing something else?
No,
Are you still doing that?
no, I'm finishing.
Oh, okay. Ethan, you're done, right? It's on the screen. It should be, once you click on the linear, it should be right there on the screen.
So like the line?
Say that again?
The line or not the effective that?
Yeah, so did you write your equation down?
No. Where it is.
Well, click on the linear.
The model?
Yeah.
Y.
equals mx plus b. So it tells you what m is and it tells you what b is. And so write those down real quick. And write down R. You got 10 seconds because I'm going to move on. Okay. Take a look at this quiz that you have on your screen now. It's going to ask you which is the correct equation. So which way is did you write the equation the correct way? And then it's going to ask you which is the correct R value. Did you round the R value the correct way? And did you look at the right one? So if you didn't finish it, just pick one, whichever one you think is the right one. Let's see if the view pops up. It should be on your screen already. Which is the correct equation and which is the correct R value? It's just a multiple choice. Is it there? Is it not there?
What?
Is it on y'all's screen?
Oh, yeah.
It's just mine. It takes forever. There it goes. So which is the correct linear regression equation? Which one was the right one? Let's choose it together.
See? Right? Or
What'd you say, Alyssa?
I said C.
You just agreeing because I said that? Okay. What? The correct answer is C, 30.1x, and it's minus 159.5 because B was negative. If B was positive, then it would be plus. Okay. Remember to make sure the M is before the X and then the B is the Y-intercept. So if you got that one right, good job. Did you do the second question? Whoops. Oh, crap. Do what? That's the correct answer. Here's next. Which is the correct rounding of the R value?
wait, how come I don't get? You only get two?
What?
It only shows up two?
Yeah, there's only two questions.
Oh, no, but like two. To answer like.
No, it should have all four answer choices.
Why did it show that?
All right, well, pick the right one on the screen. Which is the correct one? D? D? Is it C or D? What's the number after? It's 0.9575, right?
Yeah.
So the 5 rounds the 7 up to an 8. But this is D is the correct correlation coefficient. Good job with your rounding. All right. That was more of a question like, hey, do you know how to round? Okay. 5 always rounds the number up, right? Always rounds it up. Okay. 0 to 4 stays the same. That's a good question though. So based on this number alone, how strong is this correlation? What? Did you say hella strong? That's fine. Yes, it's super, super strong. And that's what your scatter plot should have looked like. And it did look like that, right? I think y'all scatter plot looked like that. Most of y'all, I saw y'all had it on your screen. So answer these last two questions and then we'll wrap up. Okay. Let's just do it together. Describe the correlation of the data. How strong was it? What direction was it? And what form is it in? We can do this in one sentence. Put it in on your screen so you have it saved for you. And I'll pull this up. I'll blow this up big so you guys can see it. Describe the correlation. How strong is it? Don't put hella on that one though. It's very strong. So it's a very strong, positive, linear or nonlinear? Is it linear? Does it form a straight line? Yeah, that one. I mean, we put a line through it, didn't we? So it's a very strong, positive linear correlation. A very strong, positive linear correlation. Very strong,
So
positive.
nonlinear is because it's scattered.
If it's nonlinear, it might make a different shape, and we're going to go over some of those shapes later on this week. Okay, but for now, very strong, positive linear correlation. And it's okay to say very, and you know for sure it's very because of that R value, right? That R value is super strong. Ready to go to the last question? Everybody submit one. You guys at home all submit one? Oh, some of y'all, oh, your phone died? Dang. All right, last question, and then we'll wrap up. Interpret the information. Okay, don't forget, hey, what does this stuff remember again? What does this stuff represent? Well, the x-axis was temperature, and the y-axis was ice cream sales. So what are we learning from this data?
The
Oh,
higher
ice temperature
temperature,
goes up.
the more so.
Yeah, the hotter it gets, the more ice cream gets sold. The hotter it gets, the more ice cream gets sold. Is that generally the case? Does hot temperature cause ice cream sales to go up, or are they just correlated? I mean, hot temperature doesn't necessarily cause ice cream sales to go up, but when it gets hotter outside, people like to eat ice cream because it's a summer treat, right? You don't see the ice cream man driving around during the snowstorm. You see him driving around out during the middle of the summer. So hotter it gets, the more temperature goes up higher, more ice cream they sell, and that's an interpretation. So again, we see the difference between correlation and the interpretation of the data, and we're going to continue to practice that over the next week or so. Everybody got their answer in? All right, now I'll just wrap up real quick. So regression, if I ask you to write a regression equation, that just means making an equation from the data. Put the data into the calculator, Desmos TI-84 calculator, create the equation. That's what regression means. Correlation coefficient is how strong the data is. What letter is correlation coefficient? The R is always correlation coefficient, not the R squared, just the R. R squared is something else. If you were into an AP statistics class, we would talk about that, not in this class. Let's see. Interpolation, make a prediction within our data. If we have something that's within our given data, that's an interpolation. Not within our data, that's an extrapolation. Interpolation, good. Extrapolation, not so good. Okay. Don't ever want to extrapolate. There's other things that can lead to that, but again, it's because we don't know if the data is going to continue to trend that way when we guesstimate outside the data. All right. Any questions? You guys at home, how do you guys do? Everything work on this Desmos for you guys at home? Give me some feedback real quick, because this is the first time I did that. Did it work for everybody pretty much? You can unmute yourselves too. Okay. All right. If you guys didn't do 7.1, take this chance to go do that. If you need to talk to me about something, send me a message. Otherwise, I will have your projects in there by tomorrow morning. Should be by tomorrow morning. And then we're just going to keep moving on to the last unit. That's it. I'll see you guys on Wednesday.